Hey everyone, so I was doing this question which says in the figure above, triangle ABC is right angled at C. If the slope of BC is 2, which of these is true for the slope of AB? Now, the thing is that because this is a right angle, we know that the slope of AC will be negative 1 by 2 because perpendicular line slopes are negative reciprocals of each other. And then I started thinking about the ASTC rule, which tells you that tan in the second quadrant is negative, right? Which means that any line that falls, which means that a line that has an angle greater than 90 degrees with the x-axis, the slope has to be negative. So then I saw that if you look at AC and AB, and you try and figure out how their angles would look, you can see that the angle, let's call this beta and this call this alpha. So beta, which is the angle for AB, is less than alpha, which is the angle for AC. So how would this affect their tangents? How would this affect their slopes? So I started doing some digging around, and you can see that in the first quadrant, tan increases from 0 to infinity. And then in the second quadrant, tan again increases from minus infinity to 0, which means that if you come this way, the slope of AB would be less than the slope of AC, which means that the slope would be less than minus half. But the interesting thing is what I found when I put in some values for tan very close to 90 degrees. So let me show that to you. So here I'm going to enter tan 90 degrees, which we know is not defined, so we get an error. Now I'm adding tan 89.999 degrees, which you can see is 5,72,957, so a very large number. And then I'm going to add tan 90.0001, which is minus 5,72,957. In fact, it's not even that, it's minus 5,72,95,780. So something magical happens at 90 degrees, that till 90, everything is positive, and after 90, everything becomes negative when it comes to tan. And it happens within the space of decimals, right? 90 obviously is not defined, but if you go a very little in the first quadrant, you'll get a positive answer, a very, very large positive answer. And if you go slightly into the second quadrant, you get a very, very, very small negative answer. So that's fun.